Right now, a small comet is putting on an unexpectedly dramatic show in our solar system. Only a short time ago, this object was so faint that ordinary backyard observers had almost no chance of noticing it. But then, within a remarkably short period, its brightness suddenly increased by thousands of times. The comet is known as 220P Magnot. It was discovered back in 2004 by Australian astronomer Robert Magnot. At the time, the comet appeared as an extremely faint object that required serious astronomical equipment to detect. That may sound surprising, because when most people hear the word comet, they imagine a huge glowing object with a massive tail. But the solid part of a comet can actually be surprisingly small. 220P Magnot belongs to a group called Jupiter family comets. Their orbits are influenced strongly by Jupiter's gravity, which helps shape the paths they follow around the Sun. Unlike some comets that disappear into the distant outer solar system for thousands of years, Jupiter family comets return much more frequently. For 220P Magnot, one complete journey around the Sun takes roughly 5.5 years. During that journey, it moves inward toward the Sun, passes through the warmer region of the solar system, and then travels back outward again. For many years, this comet behaved more or less as astronomers expected. It would become brighter as it approached the Sun. Then it would gradually become fainter as it moved away. Nothing about that routine suggested that it was about to become one of the most interesting comets being watched in 2026. Then came late May. Astronomers analyzing observations from automated sky surveys noticed something unusual. The comet had suddenly become dramatically brighter. Not slightly brighter. Not twice as bright. Its brightness increased by several magnitudes in a very short period. In practical terms, that meant the comet was suddenly thousands of times brighter than it had been before. Imagine looking at a tiny light in the darkness and then, almost overnight, watching it transform into something thousands of times more noticeable. That is essentially what happened. Astronomers call this kind of sudden increase a cometary outburst. And there is a fascinating reason why these events can happen. A comet is not simply a ball of ice. Its nucleus contains a mixture of frozen gases, dust, and rocky material. As the comet approaches the Sun, solar radiation begins heating its surface. Deep beneath that surface can be pockets of frozen compounds. Some of these materials turn into gas at much lower temperatures than ordinary water ice. If the surface develops a crack, collapses, or breaks apart in a particular region, those trapped gases can suddenly escape. And when the gases rush outward, they can carry enormous amounts of dust with them. That dust spreads around the nucleus and reflects sunlight. Suddenly, an object that was almost invisible becomes much easier to detect. This is one of the reasons comet outbursts can look so spectacular from Earth. The comet itself has not suddenly become enormous. Instead, it has surrounded itself with a much larger cloud of material. Astronomers studying 220P Magnot also found interesting chemical clues. The cloud surrounding the nucleus, known as the coma, contained a noticeable amount of diatomic carbon, or C2. This molecule is especially interesting because it can contribute to the greenish appearance sometimes seen in comet photographs. When sunlight interacts with these molecules, they can emit light in wavelengths that appear green to our eyes and cameras. So when astrophotographers capture a green glow around a comet, that color can actually tell scientists something about what is happening inside the comet. The observations also showed strong dust activity. There were indications that material from the nucleus may have broken away or that a portion of the surface had become unstable. If that happened, freshly exposed ice could suddenly be exposed to sunlight. And fresh ice can produce another burst of activity. Then the comet continued toward its closest point to the Sun. It reached perihelion in June, meaning the point in its orbit where it was nearest to the Sun. You might expect the comet to become even more active as solar heating increased. But something interesting happened instead. The comet began fading. The spectacular outburst started to calm down. Its surrounding cloud became less concentrated as dust and gas continued spreading outward into space. Images taken during this period showed the coma becoming more extended and less compact. By early August, the comet had become much fainter again. At that point, it might have looked as though the strange event was finally coming to an end. But then, on August 5, the comet surprised observers again. It suddenly brightened for a second time. This was another major outburst. And this second event made 220p McNaught even more interesting. One unexpected outburst can happen when a comet's surface becomes unstable. But two significant bursts during the same return to the inner solar system are much harder to explain. That is why astronomers are continuing to monitor it closely. The most important thing to understand is that the comet itself is still tiny. Its solid nucleus may only be around a kilometer or two across. Compared with Earth, that is almost nothing. But the cloud surrounding it can become enormous. But the most interesting question is not simply how bright 220p McNaught became. The bigger question is what this strange activity can teach us about the comet itself. Comets are often described as frozen leftovers from the birth of the solar system. More than 4.5 billion years ago, the Sun and planets were forming from a huge cloud of gas and dust. Far from the young Sun, temperatures were low enough for different materials to freeze. Some of those ancient materials eventually became trapped inside small icy bodies. Those bodies became the comets we see today. That means a comet is more than just an object traveling through space. It can also be a kind of natural time capsule. The material inside it may have remained frozen for billions of years, preserving clues about the conditions that existed when the solar system was still young. And every time a comet approaches the Sun, that ancient material becomes exposed. Heat begins changing the surface. Frozen gases escape. Dust is released. And astronomers can study what comes out. This is one reason scientists are so interested in 220p McNaught. The unusual chemical activity detected during its outburst gives researchers an opportunity to examine material that has spent an enormous amount of time protected beneath the comet's surface. The greenish glow is especially interesting because it is connected to diatomic carbon. That chemical signature is not simply a visual effect. It can provide information about the composition of the material being released. Different comets contain different mixtures of gases and dust. By studying those differences, scientists can compare comets and learn more about how these ancient objects formed. Jupiter family comets are particularly useful for this kind of research. Their orbits bring them back toward the Sun relatively often. That means astronomers can observe the same object repeatedly. Instead of getting only one chance to study a comet, researchers can watch how it changes from one solar encounter to another. Every return can reveal something new. The surface may lose more ice. New cracks may develop. Fresh material may become exposed. And the comet can gradually change as solar heating continues to affect it. Some comets eventually become much less active. After repeated trips around the Sun, easily accessible ice near the surface can become depleted. The comet may then stop producing large amounts of gas and dust. It can begin to look more like an ordinary dark rocky object. But other comets continue to surprise astronomers. And 220p McNaught has certainly done that this year. The first major outburst was already unusual. Then the comet faded. And just when observers had a chance to think the dramatic activity was over, another major brightening occurred in August. That raises several possibilities. Perhaps the first outburst created a new weak area on the nucleus. Once that area was exposed to sunlight, additional heating may have triggered another release of gas and dust. Another possibility is that the nucleus is not a perfectly solid piece. Comet nuclei can contain loosely connected regions of material. If different sections become unstable at different times, separate outbursts could occur. But scientists cannot simply look at the brightness of the comet and know which explanation is correct. They need observations. That means images from telescopes, measurements of brightness, spectroscopic observations that reveal chemical signatures, and observations taken at different times so researchers can see how the coma changes. This is where amateur astronomers can become surprisingly important. A professional observatory might have extremely advanced equipment, but there are thousands of amateur observers around the world who can monitor the sky every night. They can photograph the comet, estimate its brightness, and record changes. When those observations are combined, scientists can build a much clearer picture of what the comet is doing. The comet's tail also provides useful information. There are actually different structures that can appear around an active comet. Dust released from the nucleus can form a broad tail that reflects sunlight. Charged particles can form an ion tail that is strongly influenced by the solar wind. The two structures can point in different directions and behave differently. That is why detailed comet photographs can contain far more scientific information than simply showing a beautiful object in the night sky. And then there is the question everyone naturally asks. Is this comet dangerous? The answer is no. Despite its enormous-looking coma, 220P McNaught is not a planet-sized object. Its apparent size in photographs is caused by the huge cloud of material surrounding its tiny nucleus. Its orbit also keeps it far from Earth during this part of its journey. Astronomers carefully track the paths of known comets. Once enough observations have been collected, their future movements can often be predicted quite accurately. What cannot be predicted nearly as well is exactly when a comet will suddenly erupt. That is the strange part. The path may